Hello friends. So in this tutorial we will be dealing with the Pascal's law. What is Pascal's law? How it can be derived? How it is proved? So we will be dealing with Pascal's law. Okay, so Pascal's law. So it states that when a certain pressure is applied at any point in a fluid at rest, the pressure is equally transmitted transmitted in all the directions and to every other point in the fluid. So this is the definition of Pascal's law. So I will read it once again. When a certain pressure is applied at any point in a fluid at rest, this is very important. In a fluid at rest, the pressure is equally transmitted in all the direction and to every other point in a fluid. So this is the definition of the Pascal's law, and now we are going to see how it can be proved mathematically. For that, we will consider a large container. Let us take this as the large container. Large container with complete fluid in it. So to prove that, we consider this is in static condition or at rest. The fluid is at rest. Look at here. The fluid is at rest. And now what we are doing is we will take a very infinitesimal area, small area here. Let us take it as here. This is the area we are considering. So we will take this area into calculation. So now we can draw it here. So we are enlarging that area like you see here. What we are doing is we are taking an area. So what is this? This is our area, and we are taking it as x. This is y direction and the z direction. So since it is said that it is an infinitesimal area, we will take this distance as very small, denoted by dx, this as dz, and this distance, or this is say this distance as dy. and one more distance is that this is ds. And you may have the doubt that when we are going to prove anything, we will take a square area or the cubical area so that dx, dy and dz can be marked easily. Now you may have the doubt that why this triangular area is taken. It is because the answer we will discuss in the final stage, or in the final stage you can understand why it is taken. And also this angle is alpha. We are taking a triangular area or an inclined plane. This is angle is alpha. This is alpha angle. Now it is said that the water or the fluid is in equilibrium. So since it is in equilibrium, there will be no motion in this one, and we all know that if a shear stress is applied in any plane of a fluid, or in case of water, it will not resist the shear stress and it will move in that shear stress direction. So since this is said that, since this is in equilibrium, shear stress is equal to 0. So that means that the tangential component of any force acting in the plane is 0. It means that all the forces acting are normal to the surface. Normal to the surface. So now we can take the forces acting. We can now take the forces acting. Forces acting on the fluid element. Forces acting on the fluid element. So in the x direction, you should see it as a three-dimensional body, and it is the centroidal part. We are marking this as or f x or 1, anything we can take fx in the x direction, and here at the centroidal portion we have fy. Also in the inclined section, how the force will be acting, it is perpendicular to, since because there is no shear stress acting, it is perpendicular to the fs. Take it as fs, perpendicular to the body. Can take it as fs. Now if you look at this three-dimensional body from here, you can see that two-dimensional figure of this one. It has like this is dx dz. We are looking from here. Okay, so dx dz, and this is ds. This angle is alpha, and the force is acting. We now mark the forces acting. This all forces are acting from the outer fluid or the surrounding fluid elements, like from here. All the surrounding fluid elements forces are acting, and this is taken as here. Okay, so this is fx, fy, this is fs. And now the this what will be this angle? This angle, if you take this angle, this is alpha, this is, what is this angle? This is again alpha, this is alpha, this is alpha, this is alpha, this is 90 minus alpha, and this is 90, and this angle is alpha. This is acting in this way, acting in this way. So forces acting on the elements are Fx, Fy, Fs, and the final force acting it is the self weight and the W of fluid element. The self weight of fluid element. Now we will look into what is Fx, Fy, Fs. Okay, so what is Fx? Fx is the force acting in the x direction. So let's take this, the pressure acting in the x direction as Px, Px. Pressure acting in the next direction as Px. So the force acting is equal to the pressure into area, that is pressure acting, that is Px into area. What is that area? Area is the dz into dy, projected area. dz into dy, dz into dy, that is Px into dz into dy, that is Fx. Now the value of Fy, so the value of Fy is Py, that is Py, pressure in the y direction, into the corresponding area, that is dx into dy. Now the Fs is equal to Ps into pressure acting in the x direction, that is Px, Py, Ps is the pressure acting in the s direction. Ps into ds, that is this distance, ds, this distance, ds, ds into this distance, that is dy. And finally, what is the value of W? W is the weight of the fluid element, that is W is equal to the specific weight, that is the weight per unit volume, that is specific weight. Let's take it as small w, the weight per unit volume of the liquid, weight per unit volume into total volume of the fluid element. What is that total volume? Total volume is half into dz into dx into this dy. No, w into half into dz into dx into dy. It is the total volume, and total volume into weight per unit volume will give you the total weight of the fluid element. Now we know all the forces acting on the fluid element. So now we can take the equilibrium condition. Equilibrium condition. For that, we have dx, dz, ds as the element, and the forces acting are F, Y, Fx, Fs. This angle is alpha, this angle is alpha, alpha. So one more force is there, that is W, weight of the fluid mass. So we take the sigma Fx is equal to 0. So in equilibrium, so it is given that the fluid is in rest, so the equilibrium condition should satisfy. So sigma Fx is equal to 0 is means that the force in the x direction, that is, this is taken as x, this is taken as so this is the z direction, and the x direction is equal to 0, and also in the z direction or the vertical direction the force will be equal to 0. Okay, so we have a correction here. This is the Fz, not Fy, Fz, because it is acting in the z direction. Okay, so we should do it in the this portion also. This is not Fy, it is Fz, because it is in the z direction. No other changes is there, it is in z direction only. So change that y into z, only that much needed. Fz is equal to pz, Fz is equal to pz into dx into dy, pz into dx into dy. So in sigma Fx is equal to 0, what are the forces acting in the x direction? So this we take it as we take this as the positive direction, this is the negative direction, positive, negative, likewise. So in the Fx force is acting positive, so the Fx sigma Fx is equal to 0 implies Fx plus first force, second force is this Fs. You know that Fs is acting here, this is alpha, so there will be a component in the horizontal and vertical direction. So in the horizontal direction the component will be Fs sine alpha, and in the vertical direction it is Fs cos alpha. So what we can see that this is Fx plus Fx, and plus we have the algebraic, we are taking algebraic sum, plus Fx plus what is that second force value, it is in the negative direction, in the negative direction, so that is minus Fs sine alpha is equal to 0. What it means, what is the value of Fx? Fx we can write it as px into dz into dy plus minus fs. What is the value of fs? ps into ds into dy sine alpha is equal to 0. We can write in this way. So now we are looking at this portion, ds and sine alpha. Consider this one. This is alpha. This is dz dx ds. So from this, what is the value of sine alpha? Sine alpha is equal to dz by ds, means dz is equal to ds sine alpha. ds sine alpha. Also, if you take the value of cos alpha is equal to dx by ds or dx is equal to ds cos alpha. Okay, so put this value in this equation, you will get px into dz dy minus ps into ds sin alpha is dz into dy equal to 0. Now you can take the px minus ps outside into this is equal to 0. It's because dz into dy cannot be 0. That is why px minus ps is equal to 0. If you take this dz into dy outside, then you can write it as px minus ps into whole into dz into dy. But the dz into dy cannot be 0 because that is a length. Okay, so px minus ps is equal to 0 and the value is px is equal to ps. You can write it in this way. Now we take in this sigma f z is equal to 0. What it means that the forces in the z direction, algebraic sum of forces in the z direction is 0, and the value is we will take it in the positive direction, that is plus fz plus minus into the vertical component of the fs, that is fs cos alpha. One more component will be there, that is that in the which direction, the negative direction, the weight minus w, all this is equal to 0. All this is equal to 0. So what is the fz? Fz is equal to pz into dx dy plus minus ps into what is ds dy into cos alpha minus half of specific weight small w into dz dy into dx. This is equal to 0. Now, what is this value? ds cos alpha. It is ds cos alpha d ds cos alpha is equal to dx. Dx is equal to ds cos alpha. So put the value here. You will get pz into dx dy minus ps into dx dy minus half w dz dy is equal to 0. Now you consider this portion, this portion, this portion. You can see that it is a multiple of dz times dy times dx. So it is becoming very infinitesimally small numbers, insignificant number. It is contain three infinitesimal numbers dz dy dx. So it will become 0. Now we can there write the equation as pz into dx dy minus ps dx dy is equal to 0. It implies pz minus ps is equal to 0 implies pz is equal to ps. So you have two equations here. Px is equal to ps and again that ps is equal to pz. What it means? It means that you have the two equation. We have px is equal to ps and pz is equal to ps. Implies what? Px is equal to ps is equal to pz. Now you take that. Consider the figure again. It is px. This is pz. This is ps. What all of this? This is the pressure in the x direction, pressure in the z direction, and the pressure in the s direction. This is alpha. Now you consider this alpha into any other value, because we have selected this alpha is arbitrarily. This alpha can be varying. What it means? ps can be varying in any direction and it will not depend on alpha. In any direction this ps will be equal to pz and again this 2 will be equal to px. So it is because we took the portion, we took the element as a triangular one to prove that even though this alpha is varying, we can get the same value and the final result will not be depend on that alpha. Okay, it is because that we took the wedge shaped element. So px is equal to ps is equal to pz means that pressure in every direction will be its same. Okay, so friends, I hope you clear the derivation. If you have any doubt, post it in the comment section, and if you like the video, please don't forget to like, share, comment and subscribe the channel. So friends, more tutorials will be uploaded in the next videos. Thank you.